Jason Dietz, and I'm from the Federal Highway Resource Center. And we're partnering with the Pavement Preservation and Recycling Alliance, PPRA, on a series of these pavement preservation webinars focusing on pavement preservation. Today's webinar will focus on how to construct high-quality slurry microsurfacing treatments, Part 1. You will see a number of polls up on the screen, and we ask you to take a time to answer those, and we will close them in just a few minutes as the presentation begins. We also encourage questions during the webinar, and we ask you to please take the time to respond to the evaluations as well at the end of the webinar. All attendees are on mute, but you can submit any questions through the chat function on your screen, and we will answer those as time permits. We will be offering PDHs for today's webinar upon request, so please let us know after the webinar if you would like to receive that. I'd now like to introduce today's speaker, Tim Harwood, representing International Slurry Association. Tim is the manager of the Southern Contracting Division for Vance Brothers Incorporated. His area of operation includes Alabama, Louisiana, Mississippi, Tennessee, Arkansas, and Oklahoma. He started in slurry seal and microsurfacing industry 32 years ago in Little Rock, Arkansas. Tim has participated in the placement of slurry seal and microsurfacing in multiple states along several Central American countries. He has served on the ISSA Airport and Specifications Committee and chaired the Slurry Systems Workshop for 7 years. Tim served on the ISSA Board of Directors for 8 years and served for the president of the International Slurry Surfacing Association in 2010. He served as the chairman of the ISSA Technical Marketing Webinar and Web-Based Training Committee, which produced 3 web-based training modules through a cooperative agreement with the Federal Highway and ISSA. He currently serves as a vice president of the Foundation of Pavement Preservation, FP Square, and sits on a committee that helps design and implement the current preservation group study at the National Center of Asphalt Technology at Auburn University. Tim, on behalf of PPRA and FHWA, I want to thank you for your time today, and I'll now turn it over to you for your presentation.
Jason, thank you, and Nicole, thank you for the introductions. And I guess while we start, Jason started with a couple of polling questions. One of them is going to be covered within this webinar, and looks like everybody's knocking it out of the park. They're on how often to clean the spreader box, and everybody's spot on there. We do it periodically throughout the day as needed and do a more extensive cleaning at the end of the day. When it talks about how to reduce time for holding up traffic at intersections and things of that nature, sanding and blotting the pavement after the material has broken and started to cure, lets you get traffic across that intersection without doing any damage to the vehicles or the material itself. That will not be covered in today's presentation, but it will be covered extensively in Part 2 that we'll see coming down the line. So just to give you an idea that everybody looks like they've got the right answers on that. So we'll go ahead and kind of move right into the presentation. First of all, I just want to thank everybody for taking time out of their busy schedule to be here today. And I want to let everybody know we've got kind of a little disclaimer here at the beginning, and it is not intended or recommended that this training be used as a verbatim specification. It should be used as a guide to assist contractors and user agencies with the information necessary to construct a high-quality project. Contractors and agencies should understand that almost all geographical areas vary as to the availability of materials in different weather situations, and an effort should be made to determine what materials are reasonably available, keeping in mind system compatibility and specific job requirements. Okay, we have to pick a starting point for this presentation that really kind of gets into the weeds of how to perform a high-quality slurry seal and microsurfacing project. So we had to make some assumptions to pick a starting point. So these are those assumptions. The first thing we assume is that we've chosen the right candidate for the job. So proper site selection is involved there. The project has been bid, project has been awarded, Mix design has been submitted and approved by the user agency. Pre-construction meeting has been held. Materials are on site and approved for use. So that's kind of the starting point of this presentation. And I guess before we go any further, I want to let everybody know that this presentation is kind of a distillation of information from the ISSA Inspector's Manual, which was the source document for the Federal Highway Administration and the ISSA web-based training modules out there. And, you know, it's limited on time, and it does not cover everything that is in that manual. So there's other avenues to get more information on this, but today we've got about 90 minutes, and we've kind of cherry-picked some things out of that manual that are of high importance, and we're going to stress those today, and then we'll continue in part 2 stressing some of the other ones in that manual. So don't hesitate to go take that web-based training. It's free, it's great, and then we'll talk about the Inspector's Manual availability at the end of the presentation. First thing we're going to do, and everything seems pretty simple, but we're going to talk about stockpiles. They're a little bit different than your ordinary stockpiles that you may see for a paving operation or a chip seal operation. So we'll start there, and we'll just kind of give you a drone view of what a typical slurry seal or microsurfacing staging area may look like. You can see the big frac tank down the left-hand corner. That's good for emulsion storage. You can see at the time of this picture that a transport with new emulsion is being delivered and pumped into the storage tank. You can kind of see the screening plant, the front end loader, all the pallets of Portland cement over there with the blue tarp, and of course the aggregate pile. This is kind of a typical stockpile arrangement. You want these things located in a centrally located area to the project. You want them high and dry, so if you get a rain event, you don't have problems. And you don't want them too close to houses because of the noise that's going to be generated from all the equipment coming in and out. So just kind of an idea of what the staging area may look like. Now, one of the most important things that takes place at the staging area or stockpile is a screening of aggregate. And I realize not all parts of the country have the capability of screening their aggregate on site due to dust abatement concerns, but in a large part of the country, it is possible, especially in our area where we typically have 3 to 6% moisture within our aggregate. Dust is typically not a big issue with screening, and ISSA recommends that you screen the aggregate directly into your support vehicles or truck-mounted units. That way you eliminate any possibility of oversized aggregate material making out to your laydown machine. If you're allowing the screening of aggregate back onto the ground, it's very easy for a front-end loader operator to get a little bit too low and pick up some gravel and some deleterious material and load it into that truck. So this is kind of a fail-proof way to make sure that you don't have a lot of oversized material going out to your laydown machine. Now, in this picture here, what we're trying to illustrate, and I'll see if I can figure out this pointer, you can see these big, large pieces of aggregate. Now, what those are conglomerates. Those are fines that have stuck together, while stockpiled and it's been rained on and things of that nature. It's not oversized particles of aggregate, but it's still important that they be removed. You don't want that to make it through to your machine. It can block the aggregate gate, feed gate going to your pug mill and cause you all kinds of troubles if it goes through your pug mill and gets in your spreader box. So, this could have been over a several week period of time that the material that was screened out of that product, but that little bit of material there can cause an enormous amount of trouble out on the pavement that you're trying to cover. So it's important that if you can screen the aggregate, that we recommend that you screen 100% of it directly into the unit as they're on their way out to the machine or into the machine where they're going to lay the product. So the next one is surface preparation. And within surface preparation, there's two phases. There's an early phase and there's a final stage. And the early stage includes items such as crack treatments, structural leveling, full depth repairs, tree trimming, which a lot of folks don't consider, herbicide treatments, and then tack coat when required. You need to consider repairing all your utility repairs in or around the areas to be resurfaced, culverts, and items like that. If you got any breaks in your concrete, curb and gutter, driveways or sidewalks, those things need to be repaired prior to your slurry or microsurfacing contractor coming in to install their treatments. You want to patch all areas showing pavement and or base failure. You want to level up uneven areas in the pavement surface. Sometimes they call that structural leveling. And you want to level or fill wheel ruts. That can be done with microsurfacing in some cases. In other cases, you can use hot mix asphalt. And then with all thin non-structural surface treatments, we recommend that you crack seal cracks larger than 1/4 of an inch. And then also treatment of vegetation intruding or through the asphalt pavement with a good herbicide treatment is extremely important. And I'm going to show you some very interesting slides on that as we move forward. And then we want to clip the shoulders back. If over time the edges of the roads have built up earthen material and it's not allowing the water off, then we're just exacerbating any problems that we have out there. We want to make sure we clip those back, shape them to where that water can get off of that road. And then, of course, we want to trim the trees to make sure that the equipment has access to the pavement itself. So when we talk about crack treatments, we want to make sure that we're using a compatible sealer, and it's extremely important that we make sure that the amount of sealer that's remaining on the pavement surface should be minimal. Some people like to do a route and seal. Some people use a blow and seal. Both methods are very effective if you follow the two number one rules, is that the crack should be clean and dry. And the major important thing to remember when doing crack sealing in front of these thin surface treatments like slurry seal and microsurfacing is that you leave a minimal amount of material remaining on the surface. And the reason I say that is it can create some constructability issues. If you leave a thick membrane of crack sealing material on the surface, spreader boxes and construction traffic can tear and rip and compromise the seal that you worked so hard for, and that's not what the goal is. So if you're going to blow and seal, make sure you use a V-squeegee and wipe that down to where you have a very thin membrane of material on top of the paved surface, and you won't have any problem. If you have any questions about how to put together a good spec on it, you can go to the ISSA website, which we'll show at the end of the presentation, and look up the A175 recommended performance guidelines for crack sealing. When we talk about full depth repairs, we want to make sure that we square these repaired areas off, use our best practices, go down until we find suitable material as far as base material goes, and bring it up in stages, and do patches that are represented in this picture here. Those are exactly what we want, and as we apply our treatments over areas like that, we can expect that we're going to get maximum performance in those areas because they were performed properly. On the other hand, going out a week or so before the crew shows up to town or on the job and throwing a truckload of cold mix down and blading it out with a grader and rolling it with a dump truck yields you results such as this. There's obviously some base issues here, and this is what we don't want to happen. It causes constructability issues, and the performance over time is just not going to be adequate, and agency is going to have to be back in there repairing those areas again, and that's never a good look. And people like to have when a job's finished, they like it to be a good job without any go backs. So this is what you don't want to do. Tree trimming, like I mentioned earlier, it's not too big of an issue unless you're on a urban arterial with the DOT type work, but if you're doing residential work, you have to have access. This equipment By the time you have safety rails and things of that nature installed on top of it, can be 12 or so foot higher. Really, this type of activity needs to take place well in advance of the crew showing up. If the crew shows up and they can't get to the pavement, then they're left with trying to handle tasks that really aren't their forte or not in their area of expertise, and really it can make a mess and delay progress. So something that needs to happen well in advance. Herbicide treatment. We want to remove the vegetation, but we also want to retard its future growth. And I've learned one thing over my 35 years in this business: there's no better fertilizer than asphalt emulsion. It makes grass grow back greener and stronger than it was before you covered it up. So you want to make sure you do the herbicide treatment, and you want to make sure that applicator complies with any OSHA regulations and follows any information off the material data safety sheet. Now, this is the stuff I was telling you I was going to show you that's very interesting, and I had to go no farther than my own street to take these pictures. And having been in this business, again, for 35 years, I know the damage that grass can do to a paved surface. And you can see in 3 of these pictures where this Bermuda grass had grown through the pavement. It didn't encroach over the top of the pavement. It actually grew through the pavement. And in the bottom left-hand corner picture, you can see the destructive nature of what happens, okay? And yes, you can remove that vegetation before you resurface it, but the damage is really kind of already done. Now, with a little bit of herbicide treatment, about twice a year, you see the bottom right-hand picture, you can see no damage to that asphaltic treatment that cost so much to put in. That was actually an 1.5 inch overlay that the county paid for, and I happen to put my herbicide on there twice a year, and it stays good. If you don't, the next thing you know, your 20-foot wide roadway is going to be about 18 foot wide, and you're going to lose a big portion of what you spent so much money on. So herbicide treatment is extremely important to get it done typically a couple of weeks before the crew moves in if you've got a grass problem, and that gives it plenty of time to do its work, and then the crew can come in and remove any remnants of that vegetation and apply the treatment more successfully. Okay, now we're going to talk about final surface treatment. This is after the crew has shown up in town and all of the other items have been taken care of. That's going to include surface cleaning, structure and casting protection, pavement marking removal, and when we talk about that, we'll talk about typical paint markings, raised pavement markings, and thermoplastic markings. Okay, the final surface cleaning may be completed using the following methods, and everybody's seen these before: the vacuum-assisted brooms, the rotary brooms, blowing. We're going to talk about dirt and mud removal and how important that they are, and oil spot treatment and removal. When we talk about surface cleaning, again, everybody's seen the rotary brooms like you see on the left and the vacuum-assisted brooms on the right. They're typical. They should be on every job. They should be used extensively. And quite simply put, these thin surface treatments like slurry seals and microsurfacings will not perform if they cannot establish a bond with the existing pavement. So surface cleaning is paramount and uber important when it comes to providing or living by best practices and providing a product that's going to perform up to its expectations. So additional cleaning methods. On the left, you see flooding with water and brooming. And in this particular case, this road was coming out of a rock quarry where a lot of the quarry fines came out on all of the dump trucks and 18-wheelers that went in and out of the quarry. And of course, they're depositing all of that granular fine material on top of the pavement surface. And to expect that our type treatments would bond to that, it's just not going to work. And the only way you could sweep it and sweep it and sweep it and still not get it clean enough to where you could ensure that you'd have the bond that you wanted. So in this particular case, we flooded it with water, we broomed it several times, and got it to the point where we felt it was clean enough to support and be able to establish a bond with our materials. The top right-hand picture, blowing. You know, the road's been swept and everything's good, but the actual joint where the concrete sidewalk meets the asphalt pavement was just full of granular material. And yes, that can be laid over, but pretty quickly that stuff's going to, I'd say, would crumble and delaminate from that area. And of course, the important thing about that joint with crown roads is all the water all the rain that comes on that road crosses over that joint. So we want to make sure that we either blow or sweep or do whatever we've got to do to get that granular material out of there so we can get some material in it and seal and fill that joint a lot better so it'll be more effective over time. Down in the bottom where it says dirt and mud removal, this is a microsurfacing job where a scratch course had already been performed, and a farmer or somebody pulled out of a field and tracked a lot of red clay dirt onto the pavement. Well, the microsurfacing is going to have slurry is going to have a very difficult time adhering to that. And, you know, even brooming it like these two gentlemen are here is not going to be sufficient enough to ensure that bond that we need to perform. So getting back out there with water and brooming and or pressure washing is going to be necessary to make sure that pavement gets clean enough so you can, again, ensure that good bond. Oil spot treatments. Typically, you only see this kind of an issue if you're in a parking lot or in an area that has a lot of roadside parking. You can see the before picture down the left-hand corner. You can use some industrial detergents combined with pressure washing to help remove any of that residual type petroleum materials. If it's a little deeper into the pavement, you may get by with a light grinding to remove to the extent of the pavement, or I guess I'd say how far the material has seeped into the pavement. If it's just kind of a surface issue, then a light grinding can take that up and you'll be able to get a good bond there. If it goes deeper than that and you've got some full saturation there from years of being exposed to a leaky vehicle or whatever, you may have to treat it just like a failed pavement and do a full depth patch. But you can see here in this case, it wasn't too drastic, and pressure washing with an industrial detergent helped, and you can see the after picture perfectly adequate and should be able to get a good bond and perform over time. Structure and casting protection. Utility companies, if you want to see them mad, cover up their manholes and water valves and don't uncover them. And then when there's an emergency and they need to access that utility, they get hot under the collar, as they should. So it's important that we protect these structures, manholes, catch basins, valve boxes, and this is the way that we've found that's very effective. We tend to use a 30-pound roofing felt, and then we'll take a chip seal marker and put on top of that. We'll lay our product directly over the top of that masking. The chip seal tab will indicate where that utility is. That way it's easily found. And after the material's cured sufficiently enough, we go back, we remove that masking, and it kind of unveils that utility, as you can see in the bottom right-hand corner. And agencies and utility companies are great with that type of work. Now, you see the top left-hand corner where I say no. And the reason I say no there is this crew did a great job covering up that water valve. But what they didn't consider is that concrete. Concrete needs, if you're going to put a slurry seal or microsurfacing over concrete, it needs a tack coat. Of course, there's no tack coat on here. So this is an area, if you cover that concrete, probably within a year to two, you might see some delamination issues with the slurry seal and microsurfacing. So it's either best to either tack coat that concrete, or my recommendation would be to cover the whole concrete area with the roofing felt and mark it, and then uncover it when you're done. And I think that would produce the best results. When we talk about catch basins, the last thing we want to do in an instance like the picture on the left, where the catch basin kind of sticks onto the pavement, is we do not want to flood that catch basin with slurry seal or microsurfacing and potentially stop or impede the flow of water into that utility. That could be disastrous, and we don't want to do that. So it really takes a lot of preparation and time to mask those things off, but it's extremely important, and you can see the results of a crew that did their due diligence with all of the manholes and all of the catch basins along the curb there. It's important. You've got to do it, and if you don't, you're gonna cause some long-lasting problems. When we talk about structures such as bridges or the end of a project, we have our best luck with protecting those structures by using plastic sheeting. You can see picture number 1 up there. The crew's been in there, the traffic control crew's been in there. They've taped down a piece of thick milled plastic sheeting to protect that bridge deck. Slide number 2, the machine is pulling onto that plastic sheeting. Slide number 3, they picked up the spreader box. We'll let that material cure for a little bit until it falls into its crumbly stage, and then we'll pick it up and remove of it properly. And as you can see in number 4, we pulled that plastic sheeting back to illustrate that there's no staining on the concrete, and everything's just like it should be. Now, one thing that it doesn't show, but one of the major advantages beyond protection of the bridge deck or the end of the project here is that by following this procedure, you eliminate all handwork that you might have typically done if you would have stopped before pulling onto that concrete bridge deck. That used to be the way of the world 25 years ago. You would stop short, you'd lift up your spreader box, you'd have a lot of material on the ground, and you would rush around trying to handwork that material into place and try to get it done so in a manner that looked as close as possible to that of the box applied material. And even as good a work as you can do, it's never going to be quite the same. So this just eliminates all handwork, eliminates any problems with staining the bridge deck. It's easy, it's effective, and we kind of recommend protecting structures like bridge decks and the end of a project with this system. Now, let's talk about pavement markings. On paint markings, your typical waterborne paint, no action is required. There's no removal necessary. On raised pavement markers, we definitely want to remove and replace those things. They typically, as far as retroreflectivity goes, probably only are good for 5 or 6 years anyway. Again, if you try to lay over a raised pavement marker, it's going to have a great influence on the screed. You're going to have some hydraulicking of material out and around the pavement marking. You're going to create a lot of handwork trying to take care of that excess materials that flows out from the screed in these areas. So just 100% remove and replace. When we talk about snow plowable markers that are recessed in the pavement, you absolutely have to remove and replace those as well. And then we'll talk a little bit more about thermoplastic pavement markings, which requires action as we move forward. Here's an example of one of the raised pavement markers that I've talked about. You can tell that they've swapped out. One pavement marker is no longer there. It probably lost its effectiveness. It was removed, and a new was installed. It has to be removed prior to any slurry seal or microsurfacing project. Trying to mask it off is not going to do anybody any favors. Snow plowable markers. They are recessed into pavement. They typically have a reflective lens on them. And as I said before, ISSA recommends that these markers be removed in advance of any slurry system treatment. And when you remove them, typically you have to use a jackhammer to do that. Then you want to patch that cavity left by the removal process with a high-performance cold mix, and do that several days in advance of your treatment being installed. Pack it down good, and then when the project is finished, reinstall that treatment. Now, what you see in this picture here is problematic. The agency wanted to save that marker in an effort to save money, and which is interesting because there's no retroreflective portion of that marker still left in place. It's gone. And for the entire 8-mile project that I rode, it was that way. So not a lot of reason to save it anyway. But secondly, what they've done by masking that off is they've created an area that will pond water during rain events. And you can see there's a high level of distress in this pavement already. It's very coarse and oxidized, and I'm sure very permeable. And to have this happening every 40 feet or every 80 feet on a construction joint is probably not the best program to expect good performance out of. So try not to ever do this. We recommend that you remove them and replace them, and you'll be well satisfied with the performance of our treatments if you do. When we talk about thermoplastic pavement markings, and it's just recommended all thermoplastic pavement markings in excess of 4 inches wide be removed or at least abraded prior to slurry surfacing installation. The acceptable method of removal includes grinding or water blasting, and about an 80 to 85% removal rate will ensure a good bond. And 80 to 85%, we like that. If you try to do 100%, you tend to get into the structure of the pavement itself, and there's no need for that, especially when the whole goal is just to ensure a good bond to that treatment. And we talk about in excess of 4 inches, and when we say that, we're really kind of steering people to think about crosswalks, railroad crossings, stop bars, arrows, words, things of that nature that are typically installed in areas where you have twisting, turning, torquing, starting, stopping type traffic. Those areas are large and, like I said, need to be abraded and removed to a large extent to ensure that you have that good bond. So always keep that in mind. When it comes to water blasting, it's a great process, but you want to be careful using that process in a pavement that has a lot of cracking in it. It is so high pressure that if you've got a 1/4 of an inch wide crack, with that pressure, you may have a 1/2 inch wide crack by the time you're done water blasting in all of those areas where the pavement markings reside. So it's a great process. Just be cognizant of the fact that if you got a lot of cracking, you might want to consider the grinding. Tack coat preceding a slurry system treatment. As per ISSA recommended guidelines, tack coat is normally not required unless the existing pavement is extremely dry, oxidized, or is concrete or brick. If you do require tack coat, ISSA recommends diluting at 3 parts water to 1 part emulsion and applying it at a 0.05 to a 0.10 per square yard. And if you do that, you want to make sure you allow the tack coat to dry before installing the slurry system treatment. Jason, do you have a polling question there you want to? And I'll give everybody a minute here to respond to those things. And again, great crowd here, knocked it out of the park on the bonding question. That's perfect. And let's see here. And everybody's paying attention. Great job, folks. Okay, moving forward. Now that we've got the surface prepared, we're going to talk a little bit about traffic control for these type of treatments. Why do we have to concern ourselves with traffic control? Well, first of all, for the safe passage of the traveling public, we want to also protect the workers that are performing the work, and then we also want to protect the product. You know, it's a period of time in the infancy of these treatments, or the infancy of the installations, that you really have to keep people off of it, or otherwise you're going to have to go back and do some repair work. So those are the 3 reasons that we do it. When we talk about traffic control devices, the needs vary based upon the situation. You can see the situation in the picture. It's an urban arterial, a lot of traffic, and a lot of cross traffic, and to keep them out of those 2 center lanes, we had to use an enormous amount of delineators, and you can see the ribbon that is strung from each one of those delineators, and that's how sometimes you have to keep people out of it. You don't want people walking through it. You don't want bicycles going through there, and you definitely do not want vehicular type traffic. And those are the extent that you have to go to at times to make sure you're protecting both the traffic, the people, and the product. Now, I always recommend this. Agencies should consider specifying it, and contractors should obviously consider having their employees certified through Issa as far as traffic control flaggers, technicians, and supervisors. I think it keeps them abreast of all the different traffic situations that you may find yourself in, and I think just creates a little bit safer environment for everybody involved out there. And as always, you want to stay in compliance with the Manual on Uniform Traffic Control Devices. And I typically ask this as a question when I'm in front of a group. Today it's just going to be a statement, but I can tell you that the largest subscribers to the Manual on Uniform Traffic Control Devices is not engineers, it's actually attorneys. So when you do not comply with traffic control plans, sometimes the attorney will see that and he will take full advantage of it. So keep that in mind and stay safe out there. Notification. Simply put, I've been doing this for 35 years, and I have learned that an informed public is a good thing. When they don't know what's going on, it creates a lot of trouble. And just like with surface preparation, when we talk about notifying the public, we have both early and final stages of doing that. And again, like the statement says, it can yield positive results from the traveling public and the agencies and the contractor performing the work. I can tell you it is to the advantage of all involved that they be kept abreast of what's going on. Now, during the early stages, the agencies can post things in the newspaper, on the radio, cable TV, websites, or message boards like you see going down the highway on DOT highways and things of that nature. You can also hand out things to subdivisions or HOAs that indicate the roads that are going to be completed in their neighborhood, who the project manager's name may be, who to contact with scheduling questions, things of that nature. Call it the first stages of notification that are done in advance of the contractor mobilizing to the job to do the installation process. Once the contractor's there, the second stage picks up, and they'll go door to door, typically 24 hours in advance, letting the residents know that, hey, you got the notification a couple of weeks ago that there's going to be some road work taking place. We're here to just inform you that we're going to be out here tomorrow resurfacing the road. Here's some instructions. Here's who we are. If you have any questions, there's some phone numbers on this document. Please feel free to call us. And then the very last part of the notification process is to just prior to doing the road. So 24 hours after you've notified them, you're on the road, you're getting ready to get started. We found it best to knock on those doors one more time to just let them know, hey, we're here, we're getting ready to get started. If you need to leave or if you need to do anything, kind of now's the time. And this process, although not foolproof, it does work very effectively, and it's better than them not knowing. That's all I can say is notification is a good process. And it also gives the agency the opportunity to inform the public of what the objectives of the project are, especially as it comes to pavement preservation. It's a good opportunity to use that and pass along that information and technology stuff so the actual residents and taxpayers really kind of get the gist of what's about to take place. So some additional things we do, especially on street side parking, in addition to the door-to-door notification, no parking signs. Put them up, put violators will be towed. You got to clear the road. There's nothing worse than when you've got 50 homes on a road and 49 of them have complied with the notifications, and one person has a vehicle parked on the road and you can't get a hold of them and can't get them moved. And the next thing you know, everybody in the neighborhood is affected by the one person that doesn't comply with the request. And on the right, it's just kind of a notifier that we put together. They can be tailored to address any of the situations that a contractor agency may find on a particular project. But again, it's another avenue to get information in their hands. You can put information about deliveries or people coming to mow the grass or sprinkler systems that you need turned off so that they don't damage the freshly installed material right after you've installed it. Again, like I said, you can tailor it to the situation, and if nobody's home, you can leave this flyer on the front door, and that way the people kind of have an idea what's coming the following day. Application. Let's talk about it just a little bit. The outline for the section on application is going to be ambient conditions for the application, slurry systems bonding, scratch coats, spreader boxes and drags, rut filling, and application rates. First of all, when we talk about weather, it's important to keep an eye in the sky and kind of know what your weather conditions are going to be throughout the day. That's not as hard now as it used to be 15 years ago. Everybody's got a smartphone now. Everybody has radar and weather alerts, and it's much easier now than it used to be back when I was superintendent. And if you had a trick knee and you knew it was going to rain, you could make the right call, but a lot of the times it was a bigger gamble. So speaking of weather, let's talk about humidity. High humidity may slow down the rate of breaking and setting of the slurry surfacing material. Very true. Low humidity, conversely, can help the material dry, and that way that water has an area to go to. So humidity can have an effect, but typically it's not too big of an effect. Wind conditions. Slight breeze is always advantageous. And like I mentioned before, less humid conditions and a breeze may accelerate the breaking and setting process of slurry. We like quick setting materials. Typically speaking, most contractors do. We like to get the product installed. We like to get it cured as quickly as we can. That eliminates the exposure to people driving on it and creating damage. It also helps us open the travel way back to the traveling public in a quicker manner, and the end user is always appreciative of that. So the less time the road can be closed down, the better off everybody is, both the contractor agency and the end user. So quick cure is good. Temperatures, both surface and air, ISSA guidelines indicate minimum 50 degrees and rising, and no work should be started if freezing temperatures are expected within 24 hours. And I always like the little plug that asphalt emulsions will be ruined if the water in the emulsion is allowed to freeze. And same with the freshly installed material. If you've installed it and the moisture's not out of it and you get a freeze that night, you're probably going to see some excessive raveling and lower performance over time because of that. So again, weather's important. Keep a watchful eye on it. In this particular situation that you see on the right, you don't want to be working in that condition. So no work should be started if rain is imminent. Now, I will say that microsurfacing becomes rain resistant pretty doggone fast these days, typically within 1 hour. This says it typically requires at least 3 hours to achieve a fully waterproof state. We've seen systems, and when I say systems, that's certain aggregates and emulsions that work extremely well together. I've seen them far surpass what this says. This is kind of a protect yourself or err on the side of caution type statement. But there are systems that do work quicker than that, and you can work a little bit closer to when the actual rain starts. But the contractor knows that. He knows he's responsible for any damage caused by the rain if he gets out there and takes a chance. So he typically is going to try to make the right decision on that, and always know, just like I mentioned, it varies based upon the conditions and the materials that you may be using. Slurry systems bonded. We mentioned this a while ago about how these treatments cannot perform unless we bonded existing pavement. One way that we can help that, or help ensure a strong bonded existing pavement, is by using a spray bar. And you can see in the picture here with the little red arrow, that there's a spray bar just directly in front of the spreader box there. And what that spray bar does for us is it helps break surface tension. And if there is any type of surface contaminant like minor dust particulates or things of that nature, it kind of settles those. And again, helps with a little bit of drain down, and which is what the slurry seals and microsurfacing rely on for that bond. So, you know, it pre-wets the existing pavement, and you just want to do it at a rate to where you dampen the pavement. You don't want a bunch of free-flowing water in front of that spreader box, and this is a perfect example of that case. Jason, if you want to drag over the video, and we'll kind of show them a little bit of a video, and you can see directly under the machine and in front of the spreader box in this particular picture, you can see that it's damp, not free-flowing. Everything is just like it should be. There we go. You can see that it's damp. Spray bar's working. Everything's going well. There's a couple of other things I'd like to point out in that picture. One of them is the pilot line. And as we get a little farther into the presentation, the uniformity of that surface texture. So a couple of things that are nice there. And we jump back some. Let me move back to where we were. Okay, now that we've talked about bonding, let's talk a little bit about scratch courts. And as I mentioned, we jump around a little bit. We had to cherry pick some of these topics because of time, and don't think that we're not going to cover some situations that probably be covered in part 2 that will be given later in the year. But a scratch court can only be done with microsurfacing, and it's used to level pavements with minor transverse irregularities that are narrower than the width of the spreader box, or on pavements with longitudinal ruts less than a ½ inch in depth. You can see here on the right a scratch course that has been installed, and on the left you can see a scratch course that is being installed. Now, the purpose and the reason they call it a scratch course, and I'll see if I can grab my pointer here, is that the idea is to scratch. Well, it's not going to let me use that. Okay, my pointer's not working very well. But the thing that's important to remember when you're leveling with either a scratch course or a rut fill is that microsurfacing by the ton is expensive. What makes it so attractive is that our ton goes a lot farther than other type treatments. So the goal here is to use your regular strike-off or your regular surface course box, but put a rigid strike-off screed in it. And then you see the yellow or the red arrows pointing to the high parts of the roadway profile. That's where the scratching is going to take place. We want to make sure that we don't build the material up in those locations. We want to scratch it as thin as we can, because if we do build that up in those locations, what we've done is we have exaggerated the rut depth. And by doing so, we require ourselves to use more material than what we would have had to use if we would have just scratched it. So that's kind of the idea behind a scratch course. And I wouldn't say it's typical, but at times, depending upon the configuration of the ruts and the lane width, a scratch course can be done 6 inches less than the width of the lane. There are some safety components to that. It leaves your center line marking in a little bit longer until you do the surface course over the top of it, which could be a safety enhancement. But a lot of the times that's not the case, and you have to do a full width scratch course with a full width surface course over the top of it, and in doing so you can level these ruts that are ½ an inch or less. So now when we talk about rut filling, and again the difference, scratch course ½ inch below, rut filling above a ½ an inch. So we want to make sure that if we're going to rut fill, we want to make sure that the pavement is structurally sound for the future traffic over the expected life of the microsurfacing itself. We want to make sure that the ruts weren't caused by mechanical, or that were caused by mechanical compaction of the pavement surface and done over time. We don't want ruts that are flat and not, well, we do want ruts that are flat, not sharp, and showing dual wheel ruts. We've all been down the pavement before where you could see the dual wheel marks on them. That's not the type of areas. That's not a good candidate for microsurfacing rut fill. There's obviously a mix or a subgrade issue in those areas. You know, we want to make sure that the ruts are indentations only, not an indentation between two upward heaves. And I know that's a mouthful, but we've all seen, especially around stoplights and intersections, where you get material pushing and shoving, and in those instances, microsurfacing is not your answer. Typically, when it gets to that stage, removal and replacement of that hot mix asphalt is what it takes. We also want to make sure that there's no fatigue or alligator cracking at the bottom of the rut, because that also would indicate maybe a material or a base type issue, load transfer type issues. That's not a good candidate. And we want to make sure that the rutting is not caused by base or subgrade failure or just inadequate ruts. So you really have to do your due diligence when we talk about rut filling. If you've got a 10 or a 12 mile or 12-year-old pavement that has some slight half-inch rutting in it that's consistent throughout the job, and it didn't happen in a rapid fashion, probably going to be a pretty good candidate for rut filling. I'm not saying that you don't still need to go in and do your coring and double-check things, but it's probably a good idea. If you've got a 3-year-old pavement that's got half-inch rutting in it, you probably need to raise an eyebrow and start doing some forensics to really truly find out what the cause of that premature rutting would be. Now, when we do these ruts that are in excess of a half an inch, it's imperative that we use what's called a rut box. And they come in 5 and 6 foot widths. Those are industry standard widths. And it allows you to fill these longitudinal wheel path ruts on an individual basis. And, you know, this rut box also allows for the application of a slight rut to allow for return traffic compaction. And again, we only use this box when the ruts are in excess of a half an inch. And you can see that it's got a V-shaped configuration here and augers in it, and there's a reason for that. And this picture on the right is why. The whole idea of that V-shaped configuration is to channelize the larger particles of aggregate into the deepest part of the rut where you need the most stability. So that's kind of why it's designed that way. And again, leaving a very fine amount of material or small amount of material on the high parts of that profile. So that's important, and that's the goal of using that rut box. And it is important to know that for every 1 inch in depth of a wheel path rut that you're filling, you need to crown that material, the microsurfacing material, 1/8 to 1/4 of an inch to compensate for return traffic compaction. And you always want to put at least 24 hours of traffic on that rut filling or scratch course prior to installing your surface treatment over the top of it. And you can see this crew, they're pulling their second rut. They're pulling the inside rut last, and that kind of creates a shingle effect. So water in the interim can drain off very easily. You can see they've got a long straight edge out there. They're making sure that they're getting the rut full, and they're putting a slight crown in it. This is what you might see on a good rut filling on a good microsurfacing rut filling application. Again, before on the left, you can see the rut is going on the right. That's exactly what you're looking for, and microsurfacing can do that for you, provided you have the right candidate. And again, we've got a before picture here, and I actually took these pictures on a job that our company did, and the day I was there for a pre-construction meeting, it rained, and you can see the consistency in the rutting, holding a lot of water, a lot of hydroplaning concerns here with this. So we came in, and you can see us filling these ruts. The picture number 2. You can see the material in the spreader box, no free-flowing liquids, good kind of a stiff mix. Again, using the rut box, this is kind of mix you might see when you're looking at a rut filling application, and the contractor may also, depending upon the pavement condition, may choose to run on the leaner side of the mix design to get a good stiff and firm mix in those ruts. Putting too much asphalt in those ruts, may not be a good thing. But so you may do that, but always stay within the confines of the job mix formula when doing so. And then after, when I was able to go down for the final inspection, it was raining again, and you can see the rut filling and surface treatment in place, and you can see the elimination of those wheel path ruts, and everything's back, and the traveling public have a safe surface to ride on now. So that's the kind of work you can achieve when a good site selection is picked and good installation tactics and materials are used. You can get great performance. Now, on the back of the ISSA A143 recommended performance guidelines, there's this little guide that can help you in determining material usages based upon the depth of the ruts you may be trying to fill. So if you have some ruts you want to fill and you know they're a good candidate, you can look up and kind of specify, don't specify application rates, but you can make sure that you put enough tons and gallons in the job to cover what the material needs on that particular job is going to be. And Jason, looks like you may have another polling question here. When addressing filling ruts that are 1/4 inch in depth, it is necessary to use a specifically designed rut filling box. Looks like most of you have it correct. That is false. You only use the rut box when you get 1/2 inch and above. So good job, everybody. Now, we're going to go into, since we've been talking about spreader boxes a little bit, I'm going to speak to that just for a minute. There's a whole host of information within our web-based training web-based training modules that are available at FHWA's website and also slurry.org. They're free. There's a complete webinar on spreader boxes at those locations. Today, we're just going to cover a few of them, kind of skim across the high parts so you can have some basic knowledge about spreader boxes. Their functions are to receive and contain the slurry microsurfacing mix from the truck-mounted or continuous paver. So after the material's mixed, it's actually discharged into the spreader box, and the machine pulls that spreader box down the road, and the goal is to evenly distribute the material across the paving width of the spreader box. It also agitates that mix. It's not a final mixing of the mix, but it keeps it agitated. And when doing so, some materials, when they're no longer agitated, tend to start breaking and setting up a little faster. So it's just a little process that helps keep the material in a state that helps you get it in its place, its final location where it's going to stay for the rest of its life before it starts breaking and setting. It also helps you meter or gauge or set the amount of material that you're applying to that road surface. You can also, in some applications, use it to correct the surface profile, such as we talked about in the scratch courses there. And what's really important, and I'll talk a little bit more about, is applying a uniform surface texture. A lot of things have got to happen for you to apply uniform surface texture. It just doesn't happen. The applicator's got to be very professional in their approach, and they've got to watch their P's and Q's, and if they do that and do their due diligence on a constant basis, then they will provide a good uniform surface texture. And it also helps create clean edge lines when that box is set up as it should be and operated properly. Okay, spreader boxes should pull smoothly and evenly without vibration. They should also be pulled in a straight format. If they're not hooked up properly and they're pulling crooked, or they're jumping up and down and vibrating, that's not a good thing. There's some action needs to take place to make sure that you alleviate those issues. The machine speed should be kept uniform when pulling the spreader box. If there's a lot of fluctuation in machine speed, that can have an effect on the installation of that treatment coming out of that spreader box. Excessive speed or improper box maintenance may cause the box to vibrate or jump, leaving transverse ripple lines. We call that washboarding in the finished surface. That is never a desirable surface texture in our treatments. And in most cases, the boxes that are used today are heavy enough that this does not happen. That does not mean that there are not companies and contractors that still use the old style boxes that are perfectly capable of installing great materials and with good consistency and surface texture, but they are much lighter. And if those are pulled incorrectly or too fast, then they can actually vibrate a little bit and create some of those more severe transverse corrugation or ripple lines. So it's important, but most of the time the spreader boxes that are used and available today, typically not much of an issue, which brings up the next statement. The most important factor in determining what the allowable speed of application is or should be is the appearance and the quality of the treatment that's left behind by that spreader box. If they're leaving a great product behind them and doing 200 feet a minute or 250 feet a minute, then let them do 200 to 250 feet a minute. If at 150 feet a minute and a lighter box, you're starting to see a little vibration or transverse corrugations, then it may need to slow down a little bit. So, but that's ultimately the deal. Make sure, if it's laying good product, go ahead and lay good product. And that laying speed is affected by a lot of things. Application rate is one of them, gradation of the aggregate, viscosity of the mix, the existing surface conditions, both texture or smoothness. So the more open graded the existing surface is, the more surface demands or hunger factor, I call it, the more material demands it's going to have, and that's going to have an effect on the speed of that machine. And conversely, if it's a slick tabletop type pavement, you're probably going to be able to go a little bit faster because there is no open graded or voidy type surface that you have to fill. So let's talk about some, or at least one particular spreader box that is available and on the market out there, and it's a variable width spreader box. Allows you to adjust the paving width during the application process. Now, there are other boxes that look identical to this, but they have bolt-on attachments that, in 6-foot and 12-foot increments that you have to, take about 45 minutes out of your day to extend or contract the spreader box to the width that you want. Takes up a lot of time where you could otherwise be producing. Now, the paving width of a variable width paving box is infinitely variable between the minimum and maximum settings. They have, I think, 8-foot minimum to 14-foot maximum. They have 9-foot minimum to 15-foot maximum. I even think they've got a 9 to 16 out there right now. So depending upon the type of geometry of the pavement that you're covering, the variable widths that are available, you have to make a choice. But what's neat about this spreader box is the width can be changed during the paving process while moving and placing material. And that was not an option until, I'm going to say, almost a decade ago. And it's really been perfected since it first came into the industry, and it really helps out. Municipal work, you can leave the stockpile with the box drawn all the way in. It helps you navigate through the traffic and get to the job site without having a great big wide spreader box. When you get to the road, it doesn't matter what width it is. You measure it, you set your box in a matter of just a few minutes, and you go to work. If the next road you go to is a different width, you just reset it again with the hydraulic lever, and you're off to the races again. So Not only is does it help with productivity, it helps with you handling minor changes in pavement geometry or lane width, and it keeps you from having to do overlaps. If you've got a fixed width box and you leave the stockpile that morning and you run onto a road that you can't get the full width pulled unless you do 2.5 passes, well, the next thing you know, you're doing a half a pass, and you're probably going to overlap quite a bit as well. And not to say that can't be done successfully, but at times that can lead a little bit of buildup and can have an influence on water flow depending upon your crown, and can also create some issues with installing some good longitudinal joints. So it's a great spreader box. And of course, it requires a heavy-duty, top-of-the-line type machinery to run it, but that's what's out there these days. So it's a great box. You might consider it. Strike-offs that are used in these. Of course, we don't use steel strike-offs or screeds like they do in the hot mix paving industry. We use, in most cases, urethane or polyurethane rubber in different widths and thicknesses and durometers, which is the stiffness of the rubber in our spreader boxes. And here you can just see some examples of some 4-inch, 5-inch, 6-inch wide polyurethane rubber. These work extremely well. They're very durable, and they last a long time, and highly recommended that they be used in spreader boxes. I can tell you that a 3/8 thick by 5-inch wide with a 60 durometer is a very good standard or general use rubber. Different application rates will require a little experimentation to determine what's best for achieving the desired application rate and what's best for leaving you a good uniform surface texture. So sometimes you have to experiment a little bit at the beginning of the job, but those that are familiar kind of know a great starting point, and they eliminate that trial process a great bit because of their years of experience. Now, another thing that is used to affect the surface texture of the installed treatment is a drag. They can be made out of burlap or canvas, and I've even heard people use other type of materials over the years to varying degrees of success. These pictures show the use of a burlap drag being used, and you can see the uniformity of the surface texture that is behind that spreader box. So that's all good and well. Now, what's really important about this, and in some instances, drags are fine, but we don't use them 100% of the time. But it's really important to know that if you're going to use a drag, it needs to be kept clean and flexible and will need to be changed periodically. And when I say periodically, I don't mean periodically throughout the job. I mean periodically throughout the day. The more material that burlap material sees, the more buildup that you see on the burlap material, the stiffer it becomes. And the next thing you know, you're seeing some striations in the material itself, and then it's time to stop and remove and replace that and wet it down before you start back up. So drags can be used successfully, but they do need to be cleaned and kept flexible and changed out. Another texturing device that's used extensively is what's called a secondary strike-off. You see two different pictures here, and the idea is to show you that it has different adjustments as far as the angle in which you can put downward pressure on the material to give you the desired surface texture results. Some contractors like to run it straight up and down. Some like to run it at about a 45-degree angle like you see on the left. Again, a lot of different methods work, and you can get to the same end result in more ways than one. Some contractors do it one way, some contractors do it the other. It's just important to watch what's coming out behind that box and verify that the surface texture is what is desired. Something else that the secondary strike-off can do for us, as you see in the picture on the left, you can see this individual box hand intentionally putting a huge drag mark in the freshly installed material. And if you look behind the secondary strike-off, there's zero sign of that deficiency or drag mark in that material. And the secondary strike-off is great at doing that. And if it can keep your squeegee hand from having to get in there and repair things, more power to him. So secondary strike-off, very good. You can see the picture on the right. I would almost bet you a house payment that they did not use a secondary strike-off, and they did not clean their box very well periodically throughout the day. You can see they stopped. There's a joint there. They didn't adjust their box. They took back off, and they still had drag marks. So good box maintenance, which we'll talk about a little bit more, and a secondary strike-off can help you alleviate those type situations. Now, one of the things that's extremely important with a spreader box is obviously to keep it maintained. We're not going to go into all the things that you have to do with bearings and chains and hydraulic hoses and motors and things of that nature, but just like with any other piece of equipment, you got to keep it in tip-top shape if you're going to expect tip-top performance out of it. But more than anything, and throughout the day and extensively at the end of the day, this spreader box is going to need to be cleaned. And the best way for this to happen is, first of all, every morning before you go out to the roads or pavement that you're going to resurface, you want to treat that spreader box with an asphalt release agent. There's several of them out there that you can buy on the market. I'm not going to advocate any of those today other than do your research, find them, and use them. And then once you've done that, almost every time, well, actually every time that machine stops is typically we're going to require to scrape excess material from all the surfaces. If you don't, they'll kind of turn into a cold mix, and you'll be going down the road. That material will fall off the box into the fresh material. It will get lodged under the screed rubber, create drag marks, create handwork, and just be problematic. So you want to make sure you clean the box every time you stop, especially the strike-off rubbers and just excess material that may fall off. You know, sometimes you're going to have to heat the asphalt to get it off the spreader box. Most crews keep some type of a propane torch close by to the machine so they can do this to keep knock some of that buildup off. You got to be careful with that for safety reasons, and want to stay away from the hydraulic motors and bearings and box rubbers because it can cause you some problems there. Sometimes you have to remove and clean the squeegees or the rubbers, as you see down on the bottom right-hand corner of this. And I've seen a lot of contractors pressure wash those and have great success with that. They seem to come cleaner than they do with just scraping it off. And in the top-hand picture, you can see where the gentleman in the yellow shirt bent over scraping the rubber with a putty knife. You can kind of look where the putty knife is, how clean that rubber is, and then just to the right of that putty knife, you can see the dark material that has built up on that rubber. And of course, that material now is hard, it's set up, and if left there, it's going to have an influence on the final surface texture, which is probably not going to be good. So needs to be scraped periodically and kept clean, and it'll provide good service and good aesthetics of the material. And again, you know, grease it, keep it in good shape, and then again, at the end of the day, it needs extensive cleaning. You know, these cleanings that take maybe 10 minutes as the machine stops while you're out producing during the day, you may have to do that pretty often depending upon the situation you're in. You know, if you're pulling an 8-mile-long highway, you're not going to have to do it near as much as if you're pulling cul-de-sacs and short residential roads. So again, keep it clean, and at the end of the day, do an extensive cleaning on it. Make sure it's ready for the next morning. I don't like to see crews wait till the next morning because it's 10 times harder to clean after all that material's set up hard than it is the night before the next morning. Here's a close-up picture of a spreader box. It's been laying, and you can see the excess material built up on that rubber. If that's left there, it's going to cause some issues at some point, whether that be with texturing, whether that be with wiping it clean from the pavement, not allowing material out of the box. At some point, it's going to cause trouble. So when stopped, that material needs to be cleaned off. Jason, looks like you got another polling question. All right, looks like everybody's doing really good there. Yep, we don't want to use the same burlap drag throughout the project, and we want to keep it clean. So, okay, let's talk about application rates and surface texture. And this is the deep subject again. We're going to skim the surface here, but the primary factors that determine optimum rate of application are, first of all, the aggregate gradation and the existing surface texture, or void content of the pavement that you're covering. Want to remind everybody with slurry seal, there's 3 different types of gradations available, type 1 being the finest, type 2 being right in the middle and probably most commonly used, and then type 3 being the coarsest stone. With the microsurfacing, type 1 is not available, only a type 2 and a type 3 are available, and those gradations are identical to the type 2 and type 3 of the slurry seal. Now, I'm just going to go through a typical yield check, and we'll talk more about calibrations in part 2 of best practices here. But I wanted you to know a little bit about yield checks. We need to check several times a day to ensure that we are living up to the specified application rate in the contract. So we want to make sure we do that. I think contracts generally call for about 4 of those a day, depending upon how much you do. But through the calibration process, we're going to come up with the factors or individual material or component material output. So we're going to know how many pounds of rock we're getting per count on the counter. We're going to know how many pounds of emulsion we're getting per count on the counter, and how many pounds of cement we're getting per count on the counter. And we're going to be able to use those factors to determine our application rate. So for this instance, we're going to check an area that's 500 feet long by 12 foot wide, and we divide that by 9. It tells us that we've got 667 square yards. Okay, and everything that we do with slurries and micros is the way we, the way we check our application rate is not by thickness, but it is by pounds of dry aggregate per square yard. So what we do, if we start with our aggregate counter at 0 and we end that count at 398. So we've covered that 500 foot in length, 12 foot wide, and we've used 398 aggregate counts. Okay, we know that our calibration factor provides that we're getting 33.45 pounds of dry aggregate for every 1 count on that counter. So we multiply the 398 counts by the 33.45 pounds of aggregate per count, and it gives us 13,313.1 pounds of dry aggregate applied to that 667 square yards. So we take the total pounds of aggregate, divide it by the square yards, and it tells us that we applied 19.96 pounds of dry aggregate per square yard. So that's just a quick run, and if we get some feedback, we'll really try to get a little more into the weeds on that. But if you take anything away from it, be there for calibrations. Make sure the contractor and or the agency's oversight personnel are conducting application rate checks, because they all have influence on the performance of the product. Okay, existing surface void content will directly affect the laydown rate of the slurry system. The more porous the surface, the more material must be placed to satisfy the surface demand. We've kind of talked about that hunger factor. You know, if you're going over a chip seal surface that used 3/8 inch rock or 1/2 inch rock, then there's going to be a pretty demanding road surface with a lot of voids in it. It's going to require a lot of material. Well, if you're going over a roller compacted, densely graded hot mix asphalt, you're not going to have much surface texture at all, so it's probably not going to require the same amount of material. So keep that in mind. Finished surface texture can be influenced by a lot of different things. First of all, it can be influenced by the existing pavement surface texture, the mix consistency, and again, I want to mention accurate calibrations. And if you got to do calibrations, and I'll have a blanket statement here before the presentation's over, and you want to make sure that you've got a good mix consistency, you know, that doesn't have a lot of free-flowing liquids in it, like a wet mix where the operators use, you know, putting too much water in the mix. That's never going to be good. You want to make sure that the contractor adheres to the job mix formula and sticks with typically the I've lost it here. They typically want to stick with the middle of the road of the job mix formula. That would be the target emulsion rate, or not target emulsion rate, target emulsion percentage based on dry weight of the rock, and the same with the cement. You want to experiment with the screed rubbers, because the screed rubber definitely is going to have an effect on your surface texture. If your spreader box is not maintained well, it's going to have bad effects on your surface texture. If it's kept in good state of repair, it's going to have very redeeming and desirable effects on the aesthetic value. The use of drags or secondary strike-offs. They both will give you different surface textures, but they both can be very acceptable. I typically like to ask the agency which one they like best, and then we kind of stick with it and provide that to them. The application rate. You know, if you apply the material too thin, you're going to have a lot of exposed larger particles of aggregate that's going to look very grainy. And on the flip side of that, if you over-apply the material, you're going to have 100% embedment of the material, and you're going to have a slick, flush-looking surface. So you have to find the rate of application that provides you the best end result. Handwork always has an effect on surface texture. It can be done good, but it's always going to stick out a little bit more than what you get with box-applied material. The gradation of the aggregate, the size of the large particles of aggregate, are definitely going to have an influence on that surface texture. Speed of the application machine, we talked about that earlier. Opening the traffic too soon. You know, if an agency's nervous about traffic backups and things of that nature, or a contractor you know, pulls the trigger a little too soon and opens up the traffic, you can get some higher rates of embedment and a little more flush look on the surface. So make sure you let the product cure sufficiently enough to where it's going to handle traffic without having detrimental effects on the final surface texture or the treatment itself. And then another thing that we don't use very often unless we're on airports or parking lots, it's rolling. Rolling is done with a pneumatic tired roller. And again, it can have an effect on your final surface texture. But again, it's only used on airports and parking lots, typically speaking. Okay, surface texture, and I say high friction surface. We've known for years that we've got high friction values with these treatments. The research studies at NCAT and mid-roads have only confirmed that, and 9 years going into the end, since the NCAT study took place, the skid numbers are extremely good and well above acceptable rates and projected to maintain those high friction values throughout the useful life. So you can see the picture on the left, great surface texture uniformity. The darker colored material on the left was done the day prior. The picture was taken from the top of the machine during installation. That's about as uniform as the material can be applied. And then you can see the picture with the quarter in it, a kind of magnified version of what that surface texture can look like. And again, that can be affected depending on the size of the aggregate that you use in the material and the surface texture and whether you use drags and things of that nature. So just an idea of what that surface texture can look like. This is not the surface texture you want. It's pretty obvious what's wrong with these pictures. I don't know why I asked that question. Spreader box is not clean. They're not pulling straight lines. The material is not in control. Not the ideal application of a slurry surfacing treatment, and in my opinion, unacceptable. Needs to be redone. This is not what you want. You want to see what you saw in the picture just prior to this. One more video. Here, Mr. Jason. And in this picture, the reason we're doing it is to show you the uniformity of the surface texture here. This is actually part of the microsurfacing installation at the NCAT. Well, this is not on the test track. This is on US 280, which is the high volume sections that they've been evaluating since 2015. But you can see during that application that everything's working well. Surface texture is good. Everybody's watching what they're doing. They're staying between the lines, which they required on that job. That's the finished kind of product that you should expect to see. All right, moving along. Let's talk about inspection points. And first of all, I can tell you that you don't want to get crossways with this young gentleman in the hard hat and the vest. He's a very demanding individual. I know. He's my grandson. And the first thing I want to say, there's several things we're going to talk about when we talk about inspection points. And again, this is not a complete list. This is a cherry-picked list. There's a lot more to it. But the first thing I can tell you is the person in the truck here performing the oversight on the job, taking a nap, is not the way to perform oversight. And, I've seen that over the years when people are unfamiliar with our treatments. They tend to shy away from performing, their duties as far as oversight goes. And they kind of shy away, and they take the approach that, hey, we're relying on you to do us a good job. And if you do us a good job and it works, we'll continue to use the product. That's not the proper approach, in my opinion. I think the agency has a responsibility to perform good oversight, and becoming familiarized with the treatments will aid in doing just that. And those of you that are here today, listen to this presentation, are taking steps to familiarize yourself, so I applaud you in that. But some of the things we're going to talk about are calibration, test strips, longitudinal joints, transverse joints, and edge lines. Okay, first of all, calibration. I cannot tell you how important it is and how involved you should be as an agency if you're specifying this material, if you're a contractor, how important it is to you to make sure you're putting down the proper proportions so that you can ensure good performance of the treatment, and also know that you're putting down the right kind of materials where you can meet your estimates on the project. But with a calibration, the goal, it verifies individual component material output. It ensures that materials that are proportioned according to the parameters set forth in the mix design. That's the number one thing. If we do not mix it according to those proportions in the job mix formula, we leave ourselves vulnerable for failure. And it also aids in quantifying material usage, just like we showed you in that yield check worksheet there. It's important. If you don't have the information from the calibration, you cannot do spread rate checks. And also, some agencies use these calibration factors for pay items. If you're paying by the ton and the gallon, that's the way they will quantify those materials. That will be their method of measurement, to get their total number of gallons used and total number of tons used. So it's important on all levels, but those are some of the three major reasons that it is. Now I'm going to read you the passage out of the brand new, soon to be on the market ISSA Design Inspector's Manual. It says the application equipment is calibrated to produce a mix that is consistent with JMF in the approved mix design. It should be turned in a couple of weeks before the job starts. The mix design components are proportioned by weight, while the application equipment delivers materials by volume. It is essential that calibration be completed using the actual job site materials immediately prior to each job startup and in the presence of the buyer's authorized representative. No application equipment should be allowed to work on the job without a proper calibration. And I think the one thing that is highlighted and underlined there is a big takeaway here. Some in industry think that mixed design or calibration should be good for 6 years or the season or a calendar year and things of that nature. And in some cases, these machines are extremely consistent. I have no doubt about that. But I've learned that not only do I get a comfortable feeling calibrating on every job, knowing that I am proportioning the materials properly, but also every agency that we work for that witnesses us calibrate on every project gets that same comfortable feeling about what we're about to do. It's not a long process. Typically can be done in less than 2 hours at the beginning of the job, and it gives everybody, again, a comfortable feeling knowing that we're proportioning the materials according to the JMF in the approved mix design, and that's always a good thing. Now, directly after the calibration, what is typically done is a test strip, and ISSA, promotes the use of a test strip, and it's important that, because you can assure that adequate workmanship, aesthetics, and cure time of the mixture is achievable when applied with the personnel, equipment, and materials intended for use during the execution of the project. It should be performed in similar conditions as those expected during the actual application. If it's a daytime project, the test strip should be performed during the daytime. If it's a nighttime project, the test strip should be performed at night. And I prefer the test strip be an actual part of the project itself. Rather than going on a low-volume county road that has a chip seal on it and laying a test strip there versus doing it on a roller compacted hot mix on a boulevard, you may be looking at you are looking at two different situations. So go out and actually do this on the project, set up the traffic control, do the test strip, and my God, if everything works like it's supposed to, hit the ground running and start getting work done. And if handwork's done, just try to make it look as good as you can and as close to the spreader box applied material as possible. Things to remember when you're evaluating the test strip: proportion optimization, always within the job mix formula. If you need to adjust emulsion cement, move it around a little bit, that's fine to get the optimized product on the ground. Do it within the constraints of the mix design. You want to make sure that you verify the application rate during the test trip. You want to make sure that you've got good uniformity surface texture. You want to make sure that the equipment's in good shape, not leaking hydraulic fluid and aggregate all over the road and causing potential bond breaking situations. It's helpful that the crew have that they've got an adequate workforce. You can check cure time, make sure the workmanship's good, and check proper alignment. Once all of those things have a check mark next to them, again, round them up and let's start the project in earnest. When we talk about longitudinal joints, they need to be straight and on lane lines when possible, uniformly follow the traffic lane. They should be constructed as an overlap or a butt joint. Depending upon the thickness of the material that you're applying, I prefer a butt joint. The thinner materials and application rate, a little overlap is okay. When you start getting into heavier application, a butt joint probably should be used. If you overlap, keep the excess material to a minimum. All joints should be smooth and neat in appearance, and excessive buildup or uncovered areas should not be allowed. Here you can see a crew doing a great installation of a longitudinal joint. That's what you're looking for. All around good job here with that crew. You can see here on the left how the spreader box is positioned. It's pulling straight upon the longitudinal joint, and you can see the end result on the right. There really is no construction joint visible there So that's a very good installation. That's as good as it gets. And it takes a little work to get there, but it can be achieved. This, however, is not acceptable and should not be allowed, and is obviously going to have to be repaired. That's the flip side of the picture just prior to this. Transverse joints, kind of the same way. They should be smooth and neat in appearance. Handwork should be kept to a minimum. No excessive buildup or uncovered material should be permitted, and they should always be constructed as a butt joint. If you overlap transverse joints, you're always going to have a slight bump that you'll feel when driving over it, and that's never a good thing if you can avoid it. Some contractors find the use of roofing felt may assist them in the installation of a construction joint, but we don't use them. Just take some box adjustment attention, and then you could provide a good transverse joint. Edge lines. The driver needs something to drive off of. They need to be straight and clean. If there's nothing for that driver, the line driver, to reference, then you need to use a string line or a pilot line. String lines really aren't used. People typically do what you see on the right here. They'll pop a rope down and put a painted pilot line on it, and that's easy for that line driver to follow and provide a good straight line and good alignment on the project. On the left, obviously unacceptable. On the right, you can see that a pilot line was used. They drove down the center line of the road, and they went between each skip stripe and put that pilot line down for actually about a 12-mile long project there. But you can see the results from following that line. Very acceptable, and it's what you should expect. Okay, we want to see this crew performing a good job. You know, they're aligned well. Make it a good joint. We've got good uniformity of surface texture, and we've got proper oversight. You know, we got a person watching over it. It doesn't have to be adversarial, but contractors need to know that the agencies are looking out for their best interest. And I think when contractors and agencies work together, they achieve great things and good projects. So just an example of performing a good job. All right, I'm going to kind of finish up with keys to success. Again, this is not a complete list, but it is a good list. If you're going to get a great slurry seal or microsurfacing job, it starts with proper site selection. If you put good treatments on bad roads, then you can expect the worst, and when doing so, it'll give the treatment a bad name, the people who specify them a bad name, and the contractors who install them a bad name. So use them properly, do your due diligence. If you have questions, contact the industry, and they will help you with those choices. You need good specifications, but more importantly, they need to be enforced. You got to have that good roadway preparation, both early and final, like we talked about earlier. We got to have the proper equipment, match the equipment to the project. If you need continuous machine on the job, a big highway job, then specify it. If you have small pools, little cul-de-sacs, crossovers, aprons, things of that nature, then truck-mounted unit may be just perfect for the job, and that's what you'd want to specify. You want an accurate, thorough mix design. We've talked about that many times before, and we've got to have accurate equipment calibration. So once we do that, we need material consistency, not only from the time we send samples in for our mix design, but on day one of the deliveries to the job site and on the last day of delivery. The materials need to be consistent from beginning to end, and I always like to use material with a history of past performance. Not that we're opposed to using new sources, but it's nice to have the comfortable feeling knowing that you're using a rock that you've been using for 35 years and it's been performing forever. You want to make sure that you specify proper application rates, and you want to make sure that the contractor meets those application rates. There's times where you want to pay by the square yard, and then there's times where you might want to pay by the ton and gallon. So choose what's going to be best for you. Screening of all aggregates directly into the trucks. If folks out west with dust abatement concerns can't do that, they have to work closely with their material suppliers and trucking firms to make sure they do a really good job of keeping those oversized materials out of that. But if you can screen it, screen it. Contractor performance. You want to use a well-seasoned, well-trained workforce, and that always is paramount in getting things done. Do good herbicide treatments, have good quality project inspection. Again, agencies become familiarized with these treatments and how to perform oversight on them, and you will get better projects. Public notification, again, if they're privy to the information, know why you're doing it, when you're doing it, and how you're doing it, they are going to be much happier than if they don't have that information. And then I always say agency-industry relationship. I'm not talking about an official contract where you're partnering, but really we're all after the same thing. We're all wanting to provide the best product for the best price that we can for the end user out there. And I have learned over the years that when agencies and contractors work together in an effort to provide that, it is much more easily achieved than finding yourselves in adversarial type situations. And then information. There's tons of it out there. We've got a little slide here. Well, before I go to that, the next slide will show you some other avenues where you can gain some information. But this is just to let you know, keep your ear low to the ground. The ISSA Design Inspection Manual is due out very, very soon, and it's going to be available as an electronic version. And just checking the ISSA website at slurry.org for information on it. It's going to be a great manual, and then you can actually see a lot of the things that we were unable to talk about in today's presentation. But it's coming, and keep an eye out for it. And again, some helpful links where you can find out this other information: FHWA's website, Road Resource, the slurry.org for Issa, AASHTO Resource, and of course FP2, formerly the Foundation for Pavement Preservation. And with that, I'm going to turn it over to Miss Ann, and she can tell you about another presentation or webinar coming up soon.
Thank you, Tim. Our next webinar in the PPRA FHWA series will be held on September 16th at 2 p.m. Eastern, and that will focus on the chemistry of asphalt emulsions given by Bill Grubba with Irvine Asphalt and Emulsions, Sally Houston with BSS International, and Tony Kucharik with McAsphalt Industries. To learn more and register for that webinar, visit roadresource.org/webinars. With that, I will pass it back to Tim and Jason for our question and answer session.
All right, thanks, Ann. Well, that's it for me, folks. I, again, cannot thank you enough for your time and attention. And if we have time, we'll answer any questions that anybody may have.
Great job, Tim. I have a few things I want to talk about first before we go into the questions. As a reminder, please take the time to respond to the evaluations that's shown here. And with that, I'll get started, Tim, on some of the questions.
Okay.
Jeff Blue had a question. We have trouble with seal coat sticking on paint lines. Microsurfacing will stick to it? There's a question mark. Microsurfacing will stick to it?
Well, it would depend on the type of pavement marking. I do know that chip seals sometimes have some bonding issues, and if it's with thermoplastic, then yes, I would make sure that we remove that to a certain extent, and or abraded it enough to where you could get that good bond. Microsurfacings and slurry seals can have the same issues, but typically they're in the areas that I mentioned earlier where you have stopping, starting, twisting, turning, kind of torquing type traffic at stop bars, crosswalks, railroad crossings, words and arrows and things of that nature. We don't typically see too many issues on the straight runs and things of that nature. So we recommend anything over 4 inches in width be removed as far as thermoplastic goes. Now, if you've got some epoxy paints that have been retraced multiple times over multiple years and there's an enormous amount of buildup on it, or if they're starting to flake off, then yeah, you need to consider that as well. But that's typically not the case. But I have seen instances where other types of paint treatments have been built up and may need some attention prior to thin surface treatment installation.
Great response. Brian had a question on what is the time from the rut filling to applying a full width microsurfacing treatment?
Typically, we want to make sure that we've got 24 hours of traffic on that rut filling before we cap it off with the surface. And that's to allow for that return traffic compaction. And on a typical project that I've been associated with over the decades, we try to do all of the rut filling first. So if it's a 6-mile long job, you know, we've got 24 miles to pull that spreader box, that rut box. We do all of it first and get it filled, and then we don't start our surface treatment until we're done. That generally gives more than enough time for return traffic compaction. And it also lets us know most of those jobs are ton and gallon, and it also kind of gives us an opportunity to gauge how much material we have left for our surface treatment. You know, because rut filling sometimes can be a little tough to gauge, and it's as needed based upon field conditions. You know, you can't say, hey, an application rate's going to be 24 pounds exactly when you fill a rut, because that may be perfectly adequate in one rut depth of the job. It may be more than you need in another, and it may be insufficient in another part of the job. So that's how we typically approach those. We do all of our leveling and rut filling courses and complete them fully before we ever start our surface treatment.
And Tim, is there a few days wait before you put the surface treatment down?
24 hours is typically what's recommended.
Great. Cody had a question. What are your thoughts about using tack coat on high volume roadways, say greater than 40,000 ADT?
Well, and I'm going to tell you, tack coats, in my area of operation, we just don't use them, and we do not have delamination issues. We use the materials that we have available and have been used for decades and decades. We're very comfortable with them, and I don't think tack coats are necessary in most conditions. They may improve the application success. I'm not going to say they will improve it. I will say that they may improve it. I think, and I can't reference what the number is right now, but I believe there's an NCHRP study out on preservation treatments in high volume areas. You may try to look that up, or Jason, you may know that number off the top of your head that may give him a little bit of area to do some research there. But I'll just be honest with you, I haven't tack coated a road probably in the last 20 years in my area. Now, there may be some other areas that tack and find it necessary to tack because of a regional concern or whatever, but it's just not an issue for us. And we don't have delamination problems in our area. If we do have a pop-up, it's typically because of a surface contaminant or lack of good surface preparation technique, and they're very generally small and isolated. But
Tim,
but not
in your response, if the pavement is highly oxidized, though, would you recommend it?
Yeah, if it's highly oxidized, or concrete or brick.
Great. David had a question. Would there be a benefit of using both a drag and a secondary strike-off?
There can be, and I've seen many contractors do it, and some of our crews have tried that before. And you know, sometimes you have to think outside the box to achieve the desired surface texture that you're looking for. If you're not getting it, and I think some special situations where we've seen some deformation on roadways where there is a little bit of rutting, but the agency's not wanting us to do a leveling course or a rut filling course on it. You know, when you're laying over a road like that, it's very difficult to achieve uniformity, a surface texture, because in the deeper spots where the rutting may take place, you get the aggregate settle in there, and you get kind of a slicker, flush looking surface over the wheel path areas. and sometimes the only way you can get uniformity surface texture is to put a drag behind that to turn some of the stone over and create uniformity. So I have seen people do it and do it effectively, but I don't know that it's done on a daily basis.
Right. Edry had a question, will calibration be discussed in the second session? And I think he responded to this saying it would be, right?
It will be. Now, I can say that calibration is not a riveting subject. And I'm good enough at putting people to sleep already that I can't get too far into the weeds, but we will talk about calibration. And I will alert you to the fact that there is a full-blown calibration step-by-step procedure in the web-based training that I mentioned earlier that you can get to through FHWA's website and also through the slurry.org website. Once you register to it, you can go into it and sign up for the slurry surfacing webinars or web-based trainings, and it will walk you through it in its entirety.
Great. Brian had a question. Can application thickness be specified?
I've never seen it specified, and I do not recommend it. And there's a reason for that. And again, depending upon the surface that you're going over, if you take a probe and try to stick it down in a surface that's voidy, and the probe falls into the depth of the void, you get one thickness, whereas if the probe hits the aggregate that is not embedded in the existing surface texture, then you have less thickness. So we quantify our application rates, again, by pounds of dry rock per square yard. It's been done that way for as long as I've been in the industry, which is right at 35 years now, and I've never seen a thickness specification simply because it's just so difficult to gauge that in a proper fashion, and the underlying pavement plays such a role in that.
Thanks, Tim. Susie had a couple questions. Is it okay to check calibration one time a week during the job at the same equipment is being used?
Well, I guess it's always okay. It may not be necessary. There's these machines, I'm very confident in them. They are very consistent with their material delivery systems. And I think one calibration at the beginning of the project is adequate enough to last throughout the project. Now, there are other ways that you can, double check calibrations and application rates through the job, and that's through, you look at material deliveries. You can't have only 200 materials delivered to the job and your machine telling you that you've laid 250 tons. So, there's other ways to verify that the machine is doing what the calibration says it's doing. But I can assure you calibrations are good if they're done properly, and if they're done in the presence of the buyer's authorized representative, and that person is engaged. That's the biggest problem I see with calibrations. I see people come to them. I see agencies come to them, and they drop the tailgate, and they sit down, and they talk with other agency personnel, and they look across the stockpile, and they say, yes, they are calibrating. But they're not actually close to the machine, verifying the weights off the scales, talking with the project managers and superintendents who are doing the calibrations, and actually kind of learning how the machine works and how they bring all of those component materials together and proportion them according to the mix design and the job mix formula. So, I just say be engaged. Once you are engaged one time, you will be much more comfortable with the process and the machinery and how that proportioning takes place. But you have to be engaged.
Well said, Tim. James had a question. When you said washboarding surface needs to be redone, does this mean the contractor has to mill and remove it and then replace it, just place a second layer on the washboard layer?
Well, there may be several different methods that you can use, and it depends on the severity of the washboarding. If it's a visual thing, then you may not have to do anything to it. If it's a distinct riding, a ride quality issue, then you may, I mean, that's the first thing you try to do is you try to put another pass over the top of it, maybe with some longer skis or longer runners on the box, and try to take that out. It can be difficult. It may be best to try to use a steel wheel roller during the heat of the day to maybe knock some of that out and find a proper rolling pattern, and you may be able to minimize that effects of that washboarding. But beyond a doubt, the best way to take care of washboarding is to eliminate it before it happens. And if it starts, if you see it, then it's got, the machine's got to stop. And it's generally caused by a few things, even a burlap. If a burlap gets to kind of bouncing up and down, gets too much air underneath it, and it doesn't even have to be a dramatic bouncing up and down, but if they're going too fast and the fabric's too light and that material is kind of surging upward and downward, it can put a washboarded surface on there. So, it takes a little bit of experience to know that, but a watchful eye can see it. And if you stop and make the corrections at that point, you'd be far better off.
Great response, Tim. We have one last question, and we only have a few minutes left, Tim, so if you could respond to it really quickly. I think this is a topic that a lot of people struggle with. What are the benefits of a single application versus a double application? And real quickly, if you could respond to that. Sure.
Well, it really goes back to the distress levels that you're trying to address on the pavement. Not all pavements need 2 lifts of microsurfacing. If you have some minor deformation or rutting, then yes, that's a good approach. But if you're doing just true preservation and you've got good section and it's not terribly cracked up or the distress level's low, then one lift is perfectly adequate. So I don't like things to be spelled out in the plans as it pertains to that rather than the spec. If the spec calls for every job to be a double application, then maybe that's overusing the product in some areas. And you really need to engineer the job, evaluate what those distresses are, and determine through your experience with the treatment what's going to provide you the best outcomes.
The only other thing I would mention, Tim, is, and you'd probably agree, is the aggregate application rate being applied properly. If it's not, oftentimes that's where people go with a double, but if it's properly being done and equipment's being calibrated, you shouldn't have that issue.
Absolutely. And knowing and getting to a point where the application rates, I call it the sweet spot, knowing what aggregates and what application rates they perform best at is important. And of course, those things take time, but industry can help with that. And once you know that, you don't want to ask that a type 2 that's 98% passing the number 4 be applied at 24 or 25 pounds per square yard. You're probably not going to be happy with the surface texture at the end of the day. And conversely, you don't want to apply a type 3 material at 18 pounds per square yard because it's going to look very grainy, and you're going to have a lot of unembedded aggregate that are going to end up on the shoulder or in the ditch. So, proper application rate has to be picked, and industry can help with that, and talking with other people that have experienced it and dealt with it over the years will help you make a good choice.
Thank you so much, Tim. I leave you with the last final words, and then appreciate everybody's attendance today, and we look forward to you participating in our next webinar. Go ahead, Tim. Any final words?
My final words are just thanks so much for staying engaged and attending this webinar today. Thanks for Jason for sponsoring this stuff, and Allie and Ann for all the work they do behind the scenes, and Miss Nicole for watching over and making sure we're doing things right. You know, just I appreciate it. I'm glad everybody came to try to get some information. I hope I can provide you with something that'll help you in your future endeavors with slurries and microsurfacings.
Thank you, Tim. Now we'll conclude our webinar for today. Thank you.
All right. Thanks, everybody.